Let's learn about indeterminate forms in this video. Whenever we evaluate limits, it's possible for us to come across some expressions like it's possible for us to come across some final answer and to be in form of it will be in this form 0 over 0, infinity over infinity, 0 multiplied by infinity. We can also come across infinity minus infinity. We will come across 0 to the power of 0, 1 to the power of infinity, and also we can come across infinity to the power 0. Now, these are possible indeterminate forms that we can come across in limits. The question is, when we come across any of these, how do we solve it? What are the basic approach we are to apply? Now, this is the first one. Whenever you come across something like this, let me take for instance that you have the limit as x tends to a of function f of x over g of x. After taking this limit, take note, if you have 0 over 0 or you have infinity over infinity, whenever you have either any of these, pay attention, you are going to use a rule called L'Hospital rule. You use a rule called L'Hospital rule. And what is this rule? This is the rule. If you have any of the expression, then it is possible for me to say the limit as x tends to a of f of x over g of x is also equal to the limit as x tends to a of f n x over g n x. This term means that it's possible for me to differentiate the function. That is, I can find the first derivative of the function f prime of x over g prime of x, then take the limit. Also, after taking the limit, if I still come across either this or this, it's still possible for me again to take the limit twice, to take the derivative twice, and it continues on and on and on like that. And that's the L'Hospital rule. Whenever you come across any of this expression, it says that what I can go ahead to differentiate it and it will not change my answer. That is, differentiate this. When you substitute the limits, you come across the same thing, differentiate again. If you come across it, you differentiate again, and that is it. So let's look at some question under L'Hospital rule. So the first question is this. If I have the limit as x tends to 0 of 2 to the power of x minus 1 all over 1 plus x to the power half minus 1. So let's see. Let's first substitute our limits into it by direct substitution. Here we'll be having 2 to the power of 0 minus 1 over 1 plus 0 will give me 1 raised to the power half is 1. 2 raised to the power 0 is 1. 1 minus 1 is 0 here over 0. So looking at this, we are employing the L'Hospital rule, which also states that if I go ahead to find the d of dx of this, if you see something like the d of dx of all this expression, it means that what you have to differentiate them. Now, this is how you are going to differentiate. You are not making use of quotient rule or any type of rule. You are making use of what? Just you are going to differentiate the term independently. That is, what's differentiation of 2 raised to power x? If I want to differentiate 2 raised to power x, how will you do it? Observe. If I want to differentiate something like a to the power x, where the a is constant, you are differentiating with respect to x. The answer will be a raised to power x ln a. That is the shortcut. So my answer here will be 2 raised to power x ln 2. This is a constant, derivative is 0 over. How do we differentiate this? It's very easy. This is how you are going to do it. Here is a term on its own. So you are going to say, you bring down the power. You are going to reduce the power by 1. Then you find the derivative of what is in this bracket. Derivative of what is in this bracket is equal to 1. So I'll just leave that. Minus. If I differentiate 1, my answer is 0. Now, if I substitute into it the direct substitution, if I substitute my limit into it, let's see if it will work. 2 raised to power 0 times ln 2 all over. Here, if I substitute 0, everything here will be 1. So you have half minus 0, and that's half. So what will be my final answer here? ln 2 over half, and that will be what? That will be equal to 2 ln 2, and that's the final answer. Very, very simple. Let's take a look at another question. We are still going to be using the L'Hospital rule. So the next question is this. If I have the limit as x tends to 0 of e to the x minus e to the negative x over x. Let's substitute directly. What do we have? E raised to power 0 here is 1. Here e raised to power minus 0, also e raised to power 0, that is 1 over 0. And that's 0 over 0. That's what? L'Hospital rule. Since we have gotten this expression, if you also get this, it's also L'Hospital rule. So we can also differentiate each of the term. If I differentiate exponential, I'll have exponential minus. If I differentiate exponential, surely I'll have my exponential. But derivative of this power here will give me minus 1. Then the minus 1 will multiply this exponential to give this one positive. If you are to differentiate d of dx of exponential of f of x, your answer is just f prime of x times exponential of f of x. That is, find the derivative of the power, use it to multiply the original question you were given. That is, finding the derivative of this one will give me minus 1. If I need to multiply what I have here, I'll be having what? Positive here. So that's it. Then all over, differential of this one is 1. So if I substitute directly, I'll be having e raised to power 0 minus e raised to power minus 0, and that will give me what? E raised to power 0 is 1 minus 1, and my answer is equal to 0. And 0 is an answer, it makes sense. 0 over 1 is 0, it makes sense. It's not indeterminate. Okay? So that is it. So let's take a look at another indeterminate form. What other indeterminate form? If you have 0 multiplied by infinity, how will you come out? How will you go about this indeterminate form? Let's see. If I have the limit as x tends to 0 of x cosec x, how do we solve this? This is very simple. Observe. If I want to solve this, if I substitute directly, I'll be having 0 multiplied by, what is cosec 0? Observe. Cosec is 1 over sine x. And 1 over sine 0, what's sine 0? Sine 0 is 0. So 1 over 0 is infinity. So what I'm having here is infinity. Good. This is cosec. Everything you have here is cosec. So take note of that. Now, do what I'm having. Now, whenever you have any of this, what do you think you can do? Okay. You see, if you don't understand L'Hospital rule, don't jump to the next one. What you're having here will be reflecting you back to L'Hospital rule. Now, my aim is that, how can I convert this to L'Hospital rule? That is the problem. Okay. Let me say I'm a student and I'm trying to solve this. If I write this question as the limit as x tends to 0 of x over cosec x, I've changed the question. What I'm having here is different from what I'm having here, so I can't use that approach. Also, if I'm a student and I'm writing something like this, I can't solve the question because they are different entirely. But what of if I write this as x over sine x? Is it the same? Let's see. Remember that I have x cosec x. X times, what is cosec? 1 over sine x, and which is x over sine x, what I'm having here. Now, see, this question here, it has been written as this. So let's solve the limits from here like this. Let's substitute 0. Sine 0 is 0. 0 over 0, that's L'Hospital rule again. Now, it means that I've converted the question they gave me to L'Hospital rule. I've converted the question they gave me to what? To L'Hospital rule, which means that I'll use L'Hospital rule here. So by L'Hospital rule, L'Hospital's rule, what will I do? I'll differentiate each of them. Differentiate this to get 1. Differentiate sine x to get cos x. Then you impute. I have 1 over cos 0. And what's cos 0? 1. So that is my answer. That's for 0 times infinity. Okay, what if I have something like this? The limit as x tends to 0 of x log x. Okay, let's see. How do we solve this? Let's put direct substitution. I have 0 times log 0 is, I think that's about infinity. Also, this thing works if the answer is negative infinity, no problem. So 0 times infinity, I'll also do it this way. Now observe, what will I do? You know that this one was a trigonometric term. So I use the definition to turn it to sin x. But this one, what can I turn it? I can't say here over log x, or let me say log x raised to power minus, you will complicate everything. So what do you think I can do? Try to, whenever you observe this thing, let me tell you the working principle. Try to rewrite this question in a way that you will not change the nature of what they give you. As a smart student, if I write this thing this way, log x all over 1 over x, observe, this is my numerator, this is my denominator. Have I changed anything? No. What I'm having here is exactly what I'm having here. I just go it in another form so as to suit l'Hospital rule. Now let's see if it obeys l'Hospital rule. Remember, before you use l'Hospital rule, see, before you use this rule here, you must verify. You must verify, does what you want to solve, does it satisfy this and it? If it's not, don't use it. All right, let's see. If I substitute my 0, what's log 0? I have infinity. Look at this part. 1 over 0. What's 1 over 0? That is infinity. Yeah, l'Hospital rule. So I will now differentiate from here. So by l'Hospital rule. So let's go. I have the limit as x tends to 0. What's log x? If I differentiate log x, what will be my answer? 1 over x. If I differentiate 1 over x, I'll have minus 1 over x squared. So from here, I'll be having the limit as x tends to 0, 1 over x times negative x squared. So this, we take care of one of these. I'll be having the limit as x tends to 0 of negative x. And what's my answer? 0. If I substitute, minus 0 is 0. So that is it for 0 times infinity. Okay, let's see other type of indeterminate form. What are other type of indeterminate form? This is it. If I have the limit, okay, that's for that on this part. Okay, let's see. What of if you have this indeterminate form, infinity minus infinity? Let's solve on this. Observe this question. If I have the limit as x tends to 0 of 1 over sine x minus 1 over x. How do we solve this indeterminate form? Very simple. Observe, input your 0. Let's see what you are going to get. 1 over sine 0 will give me infinity. 1 over 0, infinity. You know, sine 0 here is 0. So you are having 1 over 0 minus 1 over 0, and that's infinity. Now, you will be like, infinity is there, infinity is there. Infinity minus infinity is 0. To you is wrong. Let me tell you something. This thing is different from 1 minus 1, 0. Infinity is just what a number that increases out of bound. If I count the number of grains of sand on the earth's surface, it's smaller than infinity. Okay, let me say a student A sees infinity to this point. Another person sees infinity to this point. Another person to this point, and so on like that. So can you tell me infinity minus that infinity give me 0? No. So they are numbers that increase out of bound. So we don't treat them as numbers. So it's different. So this is indeterminate. So what will you do? Simplify. Now, let me tell you the working principle of this. Whenever you come across this, your first step should be simplify what you have here. After simplifying, let's see what we'll get. X tends to 0. X sin x, that's the LCM. So sin x in x sin x will give me x. X times 1 is x. X in x sin x will give me sin x. Sin x times 1 is sin x. When you simplify, substitute again. What will I have? 0. Sin 0 is 0. This is 0. 0 over 0, and that is l'Hospital rule. So by l'Hospital's rule, what will you do from here? Remember, differentiate each term. Now let's go. I'll have the limit as x tends to 0. If I differentiate x, I'll have 1 minus. If I differentiate sin x, I'll have cos x all over. Look at this one. This is a term on its own. If you want to differentiate, you see, this is a term, it's not like x plus sin x. This is a term on its own, so you have to use product rule to differentiate it. That is, you see, this is where your shortcut is very, very important. No one marks your working when you are using let u be x, let v, then v du. No. You have to use the shortcut here. Now, it means that to use product rule here, keep x constant, keep the first one constant, differentiate the second one. I will keep x constant as x, differentiate sine x, you have cos x, plus keep sine x alone, differentiate x. My answer will give me 1, so I'll just leave it like that. So let's substitute. I have 1 minus, what is cos 0? What's cos 0? Cos 0 is 1, this is 0, plus what is sine 0? Sine 0 is 0, and my answer is 0 over 0. What happened by El Hospital rule again? That by El Hospital rule again. By El Hospital rule again. Why? It's still giving me 0 over 0, so you have to differentiate again. So what will I have? I have the limit. As x tends to 0, this will give me 0. I have minus there. What is the derivative of cos x? Derivative of cos x is minus sine x. Look at it. Minus sine x. So that minus will take care of this minus to give me just only sine x. So I'll be using this to write just sine x. Just sine x. Just sine x. All over. Now, this is a product rule. That is, keep the first one constant. Differentiate cos x. You have minus sine x. Plus, keep this one constant. Differentiate x. You have 1. So you are done with that. Plus, keep sine x. Sine x is the only one standing, so the derivative of sine x is what? Cos x. So if I write what I'm having here, I have the limit as x tends to 0 of what? Sine x over minus x sine x plus cos x will give me 2 cos x. So if I impute my 0 here, sine 0 is 0 over this part will give me 0 plus 2 times cos 0 here is 1. So I have 0 over 2 and my answer is equals to 0. So that is it. Eventually, my answer gave me 0. So that's how to work out infinity minus infinity. You are just going to simplify, then do substitution. It will automatically change to El Hospital rule. That is it. That is it. So the next one we are looking at is this. Now, whenever we have this form, so that's the last one. So that's the last one. So if we have 0 to the power of 0, 1 to the power of infinity, infinity to the power of 0 form, or any of this term, or any term that resembles this. So that's the one more to solve. Now observe this question. If I have the limit as x tends to pi over 2 of tan x to the power of cos x. Now, how do we solve this? This is the simplest and most interesting. What you are going to do here is that, firstly, do direct substitution. If I do direct substitution, what will I have? I'll be having, this will give me tan pi over 2 is 90 degree. Tan 90 degree will give me what? Infinity. Here, cos 90 degree will give me what? 0. So look at what I'm having. So this is the form I'm having. So whenever you are having any of this form, the working principle is this. You are going to say, let y be equals to everything you have here, the limit, as x tends to pi over 2 of tan x raised to power cos x. That is the working principle. Let y or let g, anything you want, but let y be equal to this. After that, remember that there is a law of logarithm. This power here can come down here as you have for logarithm. Because I'm having a power here, I will now add log to both sides, which means I'll be having log y equals to, you see the logarithm can penetrate these limits. So I can leave my limit outside here like this. So put my and put my what? And put my log. No problem about that. It's possible. Log of tan x to the power of cos x. Then after that, what will you do? Bring this power here down. So you're having log y equal to the limit as x tends to pi over 2 of what? Cos x logarithm of tan x. Now, what will you do from here? Now, I'll have log y equals to the limit as x tends to pi over 2. Now, observe what happens here. Let's see. Let's try to substitute. Let's try to do some substitution here. That is, if I put my 90-degree here, let's try to evaluate this limit. Let's see what we're going to get. Remember, the power has come down. Let's see. Tan cos of 90 degree will give me 0 times here. Remember, tan 90 is infinity. Log infinity is infinity. So see what you're having. So you are going back to the previous form of 0 times infinity. And if I'm having 0 times infinity, I'll find a way to bring one of them to the denominator. And let me see what I'm going to get if I write this as log of tan x all over. If I bring cos down, I'll be having sec x. Remember, cos x is same thing now 1 over sec x. Also, sec x is 1 over cos x. So I now replace this cos x as this. Okay, let's see. If I put my 90-degree here, this one is infinity, sure. What is sec 90-degree? Let me show you here. Sec 90-degree is 1 over cos 90-degree. And this is 1 over 0, which is also infinity. So what you have here is infinity over infinity. Then you are going to use L'Hospital rule. Try to replay the video once again so that you can get the concept. So let me use that now that end. By L'Hospital rule, what do we have here? Now for the right hand side, so I have log y equal to limit as x tends to pi over 2. What do we do here? X tends to pi over 2. Now, what do we do here? Observe. So, differentiate up and differentiate down separately. So, whenever you want to differentiate a log term, let me show you here. You want to differentiate d over dx of anything that have a log of a function. The shortcut for this is that f prime of x over f of x. That is, you are going to differentiate what you have, then you divide it by what they give you. If I want to do it here now, if I differentiate tan x, I'll have sec square x. Then all over this tan x they gave me, then I'm done. And that's it. Then times 1 over, then it remains this sec. Let's differentiate this sec. If I differentiate sec, I'll have sec x tan x. Okay. Sec x tan x. Now, what do you now do here? From here, this one, before you start substituting your limit, please try to simplify. What happens? Sec, one of the sec will cancel one of this sec. So I'll be having the log y to be equals to the limit as x tends to 90-degree pi over 2 sec x all over tan square x. Remember, tan square, tan times tan square. Okay? Now, what do we do here? If I substitute again, let's see, if I substitute again, okay, if I substitute again, you observe that if I have sec 90-degree, this will still give me what? Sec 90 is infinity, this will still give me infinity. It means that you are going to use your L'Hospital rule once more. So by L'Hospital rule again, what we have? Log y equals to the limit as x tends to pi over 2. I'm using L'Hospital rule again just because it gave me infinity over infinity again. So if you differentiate sec, you have a sec x tan x. And if you differentiate tan square x, this is what you will do. Bring down the power, reduce the power by 1, then differentiate tan itself. If I differentiate tan, what will I have? If I differentiate tan, I'll have what? Tan x is what? Sec square x. Let me show you what I did here. I said, if you have tan x, then square, bring down the power, reduce the power by 1, then differentiate tan itself, that's sec square x. So learn all this trick alongside this video, just like you are learning two things. Okay, so what do we do from here? So first and simplify before you substitute anything. This will take care of this. One of this will cancel one of this. Therefore, I'm having log y equals to the limit as x tends to pi over 2 of what will I have here? This is 1 over 2. Sec is at the denominator. If I bring it up, I'll have what? Cos x. Right? I'll have cos x. If I bring it to the numerator, I'll have cos x. Nice. So looking at this, what do I have? Okay, what do we have? We have something like this. We have log y to be equal to the limit as x tends to pi over 2 of, if I substitute from here directly, let me substitute directly. What will I be having? I'll be having 1 over 2 cos pi over 2. So I have log y equal to, what is cos 90? That's 0 times half, that's 0. Now, if you are too fast, you pick 0 as your final answer, and that will be wrong. Remember, I'm looking for y. I'm looking for y. I said let y be equal to everything we have here. So I'm looking for y. Therefore, my y will be equal to what? If I bring this log here, it will be e raised to power 0. This log here is in base e. So if I bring it here to be e raised to power 0, and n raised to power 0 is 1. So therefore, the answer to this limit here is equal to 1. So no more this equal to 1. Exactly. So the answer is equal to 1. And that is it. So that's how to evaluate limit of this form. And that's that for that. So comment on this video, try to share it, like, comment, subscribe to this channel. If you are new to this channel, subscribe and click the notification bell so that you get notified when I drop new videos. Thanks for watching.